Hi guys, welcome back to class. In the last class, what did we learn? We learned about access points. Okay, what are access points? They are physical devices which provide wireless connection to a wired network. Correct? We have a wired network and we want a wireless device, a tablet to connect to the wired network. How is it possible? Using a access point. Access point will provide a Wi-Fi range. Through the Wi-Fi range, any device like tablet or laptop can connect to the access point. Once we connect to the access point, we will get the internet access. Okay, then WLC, Wireless LAN Controller. We use a controller to deploy configuration into many access point in one shot. We can deploy configuration, modify the configuration, also delete the configuration. Then we saw the protocols, Wi-Fi security protocols, WEP, WPA, WPA2, and WPA3. Hi online guys, can you see my screen now? Sorry, there was a network issue. Online guys, can you see my screen and am I audible?
Yes, sir.
Okay. Sorry guys, there was a network issue, so we had to reconnect. We will take one WLC, then we require a server. We'll make this as DHCP server to assign IP addresses automatically. We will take a PC so that we can configure WLC through the computer. And we want all these devices to be under one broadcast domain. What do we need? Switch, make the connections. Come to server, assign an IP address to the server 10.10. Okay, hit enter. Wait for this to turn green. If you press this, it's like a fast forward. Okay, click on the server again. Services, DHCP. Click on Pool name will be WLC. Pool for the WLC, we will give a IP address that is 10.0.0.11. Click on add. We have added the pool. Click on save. Close this. Come to the computer. Desktop IP configuration. DHCP. It has got the IP address. Open the controller. Config. Management interface. Change the IP address to 10.0.0.11. We want this IP address. Subnet mask is 255.0.0.0. Correct. This is the IP address we gave in DHCP server as WLC IP address. We are giving the same IP address here 10.0.0.11. 255.0.0.0 subnet mask. Close this. Open PC. Web browser. HTTP :10.0.0.11. Wait for some time, it will load. Yesterday there was a problem with Cisco packet tracer. I reinstalled the Cisco packet tracer. Okay, what do you see? We have to create a username. Let this be admin. Password CCNA. Confirm password CCNA. Okay. Let me make it capital C, CNA @123. Capital C, small c, NA @123. CCNA @123. Remember. Okay. What are the options we are able to see here? System name. This you leave it to default. Management IP address, subnet mask, default gateway. System name, give it a name. Let it be WLC lab. WLC lab. Management IP address 10.0.0.11. Subnet mask 255.0.0.0.0. Default gateway. Here we will use default gateway as this DHCP address because so that this server can assign IP addresses when any device requests. 10.0.0.10. Management VLAN ID, leave it to default. Click on next. What do you see? Network name, you need to give a SSID. SSID. You see this SSIDs? Profile names, student 5G, CCNA, rack CCNA, CCNP, CCIE security 5G. Similarly, I will give student as the SSID. Now, you are able to choose the Wi-Fi security protocol. Let it be personal. Password for this. What do you want me to set the password as? It will confuse. So let it be 1 to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is an easy one. VLAN again, let it be default. Click on next. This is the IP address WLC will use to communicate with WAP. WLC will use this IP address to communicate with access point. So leave it to default. Click on next. You can see the summary. Username is admin. WLC lab. In the router, we have host name. We can rename it. Similarly, WLC lab. Country, date, time, you leave all this to default. Management IP address. This is the WLC IP address 10.0.0.11. Subnet mask. This is gateway DHCP service IP address so that it can assign IP addresses. Student password is 129. This we leave it to default. Click on apply. WLC will be rebooting. That's why this has turned orange. We took HTTP access to configure WLC. Meanwhile, let's take 2 access points. Okay guys, if it takes too much time, you can close it. Click on this once, fast forward, open this, close the browser, again. Next time, if you try to open with HTTP, it will not open. Why? Can anybody tell me why? Because this time we have a username and password. So we have to use HTTPS. What do you see? Let it load. Login. Username is admin. Password is capital C, small c, and a @123. Login. This is the GUI access of WLC. Come to WLANs. Now what do you see here? You see the SSID. We have created this profile. Close this. Open access point. Now we need to connect this to the. This is a power adapter. We need to add the power adapter to the access point. Then only it will power on. Add this power adapter. Make the connection. Yes. Did you get the IP address? What do you see? IP address 10.0.0.2 assigned. How did it get? Because this is the default gateway. Ping the default gateway for IP address. 10.3. Now we will take a tablet. Click on tablet. Config. Wireless. Here, what is the SSID? Student WPE2. Password is 1, 2, 3, 4, 5, 6, 7, 8, 9. Enter. Did it connect to? access point. Simple. Click on this. Config. Wireless. What is the SSID? Student. This is the protocol we had enabled. Password is 1 to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Hit enter. Yes, it got connected. Okay, it got the IP address also. What is it? 10.0.0.4 for this tablet. Now it got 10.0.0.7. This is 10.0.0.4. Okay. The desktop, command prompt, ping 10.0.0.7. No? 7 or 8? 7. Are we getting the reply? That's it. How did this WLC get the SSID? Because WLC was able to deploy the configuration into WEP. WLC is the controller, is having the control over access points, correct? Because of that reason, we are able to connect these end devices to the access point. Simple. This is a wireless connection. This lab was fun. Wireless connection. Online guys, any doubts in the topology?
No, sir.
Please, if anybody is facing bugs in Cisco packet address, reinstall it. Okay? Because they have fixed few bugs. Yeah. Again, download it from Cisco website and install it. Security exam. Score. There will be MCQ, fill in the blanks, match the following, simulate, testlet. Simulate means your analyzing skills, they will test. Testlet means normal, that testing your performance skills. Like in quantitative, we have no different levels of analysis. They will check, they will give you a scenario question. If they give you a scenario question, it is a simulate. They ask you a straightforward question, it is a testlet. No, you have to choose answers. Fill in the blanks will be there. Match the following also can be there. 4 to 5. Oh, what are you saying? Marks, we can't say. It will vary from time to time.
Like CCNA is of 120.
You will get percentage in the marks. They will not show you have got 600 or 650 like that. They will show you percentage. Yeah, if you pass.
We asked them to like people's actually still not. It is that the rate comes up into your guys or it will not take anything else like that can be but spend it will only get it to there.
We'll start today's topic, QoS and VPN. Small topic, okay? So what is QoS? Let's go to Paint first. Take a router. Now, in real time, we know that router faces so many traffic, correct? There are so many types of traffic this router receives. It can be data packets, video packets, audio packets, text packets, many more. There are many types of packets, correct? You have text packets, audio packets, image packets, video packets, audio packets. It receives so many types of different types of data. How does it organize? How does it maintain? Okay. How does it organize? How does it maintain? How does it avoid collision or traffic? For that, we learn QoS, quality of service. Okay. Quality of service is a set of technologies, tools, and approaches that you can apply to a network. The goal of QoS is to guarantee network's ability to reliably run applications and traffic despite limited capacity. Okay, routers have certain capacity. Based on their capacity level, they can work. But if they receive a large amount of traffic, how do they manage? How do they organize things? That is what we learn in QoS. Some QoS tools and technologies do their jobs by handling different packets differently. Okay, throttling bandwidth in certain circumstances and changing priorities on the fly. Okay, now suppose there are 3 routers. Okay, and this router has sent some packet to it. This is router 1, 2, 3. Okay, there is no congestion here. This packet will aramse go to router 2. But from router 2 to router 3, there might be congestion. So router 2 can make few changes. According to the traffic, it can transmit the data according to the need. That is called as changing the priorities on the fly. On the way, if you want, you can change the priority of the packets based on the traffic. What are the categories of quality of service technology? Okay. How do they maintain the packets? That we will understand in this slide. There are 6 categories of quality of service technologies. First, it does classification. Then it does marking, policying, shaping, congestion avoidance, and queuing. What are these terms? We will see in the next few slides. A router does classification, marking, policying, shaping, congestion avoidance, and queuing to manage the bandwidth or traffic. What are these terms? We will see in the next few slides. By these pictures, you might have got an idea what classification is, what marking is, what policying and selective dropping is. Note down these points: classification, marking, policing, shaping, congestion avoidance, and queuing. Then we will see the definition to these terms. Okay, we'll go to the next slide. So what is classification? Classification is at the core of QoS. Classification is the ability for a device to identify different traffic types so you can properly prioritize one over the other. Now, what did I tell? Let's come back here. In this paint, we have different types of packets collected, correct? Identifying each type of a packet. Audio packet, video packet, image packet, text packet. Identifying them. That is classification. After that, we have marking. Marking is actually one of the optional ones. Marking involves tagging a packet as it enters the router so that subsequent devices can recognize the traffic without needing to spend processor time inspecting it. Now, this router, as the traffic is entering in, it is recognizing what type of a packet it is. So it is also tagging it. It is recognized that this is a video packet. So it will tag it as V. Now, this is a image packet. This is a text packet. Okay. Then this audio packet. So along with recognizing what type of a packet it is also tagging that information with the packet. So that when these packets leave this router and enter another router, this router again does not have to spend time in recognizing what type of a packet it is because we have already tagged the packets. Okay. Understood classification, marking. Then we have policing. Quality of service policing allows you to set an upper limit, and when traffic hits that amount, the tool cuts the traffic and doesn't allow anymore. Now, in this bandwidth, whatever this router has, it has to fit in all types of traffic, audio packets, video packets, text packets, image packets, everything. What will happen if video packets are consuming all the bandwidth? Okay. Now suppose 5 Mbps is the bandwidth this router has. 5 Mbps. Okay. This is the threshold limit. Suppose video packets are only consuming 5 Mbps. 5 MB bandwidth. What will the router do? Router will just cut down all these video packets. It will stop forwarding the video packets. It will drop all the video packets here itself. That is policy. If the data packet crosses the threshold limit, then it can be dropped. because we need the bandwidth for all types of packet. Only if video packets are consuming 5 Mbps, then what will these packets do? Collision will happen, congestion will occur. That's why once it crosses 5 Mbps, it will cut the video packets. That we can do using policy. When you go to CCNP, you will learn policy map. That time you will understand. What is shaping? Shaping is a little bit like policying, but it's a kinder, gentler version. Shaping is for traffic that we care about. Policying might kill the packets to save the bandwidth, but shaping to hold the excess data in memory and try to transmit it later. Come back to paint. Now, as your video packets are consuming a lot of bandwidth, what it will do? It will keep these packets on hold. Okay, it will let these packets to first transmit. Later on, it will process these packets. It will not drop them in this scenario, but it will keep them on hold. It will first process these packets, transmit them, then it will start processing these packets. That's it. That is shaping. We don't drop any packets, we keep them on hold, and when the bandwidth is clear, we start processing them. Then we have congestion avoidance. Congestion avoidance QoS tools shuts down the possibility of congestion by watching a certain limit of a router and then taking action. As a router's traffic builds up, congestion avoidance tool look for the devices that run highest risk of consuming the entire bandwidth amount. Now, okay, come back to the example of video packets. We know that threshold limit is 5 Mbps, correct? This is the threshold limit. Okay, if the video packets starts taking more than 4 Mbps, okay, router will immediately get to know that this is a danger packet. It might cross 5 Mbps, take the whole threshold, take the whole bandwidth, so it will stop dropping them there itself. It takes precaution. It won't let these video packets consume more than 5 Mbps or 5 Mbps. When it crosses 4 Mbps only, router will get an alert that video packets are consuming a lot of bandwidth. That is the feature in congestion avoidance. We have tools to notify the router once the data traffic starts closing to threshold limit. Router will get an alert. Correct? Router will get an alert and immediately it will start monitoring the traffic to avoid congestion. Next, we have queuing. With queuing tool, you can instruct a router to shuffle packets around to put some most important traffic first. Come back here. Assume there are a lot of video packets. Okay. It can set priority again in video packets. This packet has to be transmitted first. This packet has to be transmitted second. This packet has to be transmitted first. So when these packets gets processed, first packet to go out will be video packet 1, then video packet 2, then video packet 3.
Or it will be between same type.
Can be same type of packets or it can be different types of packets also. Not exactly like that, but it can set priority. Among these packets also it can set priority, okay?
This thing.
Here I showed you within the video packets. Among video packets, text packet, image packet also it can set priority. Tell me which packet has more priority, audio packet or video packet? Which packet has more priority, audio or video? Audio packets always have more priority. Audio packets are always processed first, then video packets are processed. That's the priority level set by default. Because video packets consume more bandwidth. Yes, text will go first. Compared to text, audio and video, text packet has higher priority. You can set the priorities. When you come to CCNP, that's what. You will learn policy mapping. That time you will understand policy-based routing, PBR. Okay, this is QoS. Just know this 6 terms. That is good. When you come to CCNP Advanced, you will have one separate class for QoS. Okay, guys. Then we'll start VPN. Or do you need a 2 minutes break? Okay, guys. Our last topic for today is VPN. Okay. Campus networks we discussed yesterday, no? Take a 2 minutes break, then we'll start VPN. Online guys, after the class, please don't quit the meeting. Wait for 5 minutes. Management people will talk to you at 12:30. Okay?
Yeah. It was.
Okay, back to class. We'll finish this topic. It will take hardly 10 minutes. So for VPN first of all stands for Virtual Private Network. Is the easiest and most effective way for people to protect their internet traffic and keep their identities private online. As you connect to secure VPN server, your internet traffic goes through an encrypted tunnel that nobody can see into, including hackers, governments, and your internet service provider. Using VPN, we create a encrypted channel so that we can secure our network and there will be no breaches. So in VPN, we have two types. One is site-to-site, one more is remote access VPN. What is site-to-site VPN? When we enable VPN between two branches, network is home Bangalore and network is home Delhi. If we want communication between these two branches, then there has to be a secured channel. So we will build a site-to-site VPN between two branches, okay, so that any communication coming out of this branch will be a secure communication. Okay, what is the advantage in site-to-site VPN? Any traffic coming out of this building will pass through the VPN tunnel only. Okay, remote access VPN means each individual person has to have a remote VPN connection. So suppose you go to Coffee Day or McDonald's and then you have to work from there. What do you have to do? You have to connect to VPN. Yes or no? You have to connect VPN. After connecting to the VPN, you will be able to access intranet service in the company. There are few internal links which will not work without VPN access in the company. Okay? So each person has to connect to VPN if you're outside the campus. But if you're inside the campus, you don't have to connect to VPN because the whole building is already connected to VPN. If you're inside the building, this whole building is already connected to VPN. So each individual person does not need to connect to VPN. But if you're outside the campus, okay, maybe at your home or at the restaurant, and you have to work from there, that time each person has to connect to VPN. Yes or no? Suppose you and your friends go to hotel. Okay. From there, if you want to access internet, from there if you want to work, all of you have to connect to VPN individually. But if you go to office, you don't have to connect to VPN because the building is already set up with the VPN. Understood? Site-to-site VPN, remote access VPN. Okay. See, VPNs are softwares. Firewall is the hardware used. Firewall also can be hardware or software. We have both. Sophos only, no? Yeah. VPN is a encryption. We are adding encryption. Now, Telnet is one remote access protocol. Correct? It is not secure. So what are we doing? We are adding encryption. How are we adding encryption? We are just adding one line. Crypto key generate. RSA module is. Yes. And we mentioned the key 1024. Adding encryption. No. Similarly, we will build an encryption for the communication. That's it. That is VPN. Line VTY. We use line VTY. What is VTY? We're creating a virtual tunnel. This virtual tunnel we create, and for the virtual tunnel, we'll add encryption. Okay. VPN. So, difference between site-to-site VPN and remote access VPN. In site-to-site VPN, IPsec security method is used to create an encrypted tunnel from one customer network to remote site of the customer. Okay. Basically, from one building to another building, from one campus to another campus. Remember like that. In remote access VPN, individual users have to connect to the private network. Each person has to have a VPN connection. Site-to-site VPN does not need setup on each client. Why? Because the whole building is already working on a VPN connection. Remote access VPN may or may not need setup on each client. Site-to-site VPN does not require every user to initiate a VPN tunnel setup. Remote access VPN requires every remote access user to initiate a VPN tunnel setup. It's the same point. Site-to-site VPN support IPsec technology. Remote access VPN support SSL and IPsec technology. In remote access, we use two types of protocols, SSL and IPsec. IPsec is a suite of protocols, collection of security protocols. IPsec is not a protocol. IPsec is a collection of protocols. One protocol is not good enough to keep the VPN encrypted and safe. So we use collection of protocols. In site-to-site VPN, multiple users are not allowed. In remote access VPN, multiple users are allowed. Do you want to make a note of these points? Anyway, till 12:30 of the stay. You want to make note? Fine. Relax. Shall we go to the last two slides? So guys, types of encryptions we have in VPN. We use symmetric key. What? RSA. Yeah. Same. Symmetric key. This is where the key for encryption and decryption is the same, and both communicating parties must process the same key in order to communicate. If this PC and this PC is communicating, this PC will use one key and encrypt the data, send it to the PC2. PC2 will again decrypt the data using the same key. That's it. That is symmetric key process. Next we have public key. Here software is used to create set of public and private keys. The public key is used to encrypt data, which is then sent to the owner of the private key. They then use this private key to decrypt the message. PC1, PC2. Okay. A software will develop one key, public key, to encrypt this data. Okay. How to decrypt this? This company would have given a private key for these people to decrypt the data. Okay. Only this company will be able to decrypt this data. Other companies will not be able to decrypt this data. This company A is encrypting the data using the public key. Okay. And the private key will be given to the company B. Using this, the company B can decrypt this data. Okay, handshake encryption. This is typically done through RSA algorithm, which has essentially been the foundation of internet security for about 2 decades. Which subject? Which branch you are from? Computer science and crypto. So much of portions are adding. 8th standard kids are having Java certifications. Don't know what they are learning in school. 8th standard kids have Java certification.
If it accuracy don't practice.
So next we have secure hash algorithm. In this process, a unique fingerprint is created to validate TLS certificate. What is TLS? Transport layer security. It's a VPN protocol to check you're connecting to the server you're supposed to be. Without this, a hacker could reroute your traffic to their own server instead of VPN provider. These are a few VPN protocols. If you want, you can make a note of it. SSL, TLS, secure socket layer, transport layer security, open VPN, iKey v2, internet key exchange version 2, L2TP, layer 2 tunneling protocol, SSTP, secure socket tunneling protocol. Then we have WireGuard, PPTP, point-to-point tunneling protocol. Each protocol was either developed by Cisco or Microsoft or with a collaboration of Microsoft and Cisco. Many companies have developed their own protocol for their VPNs. Okay, so guys, QoS is done, VPN also done. Tomorrow we have the last topic, automation. It will be interesting. Don't bunk the class. Wireless lab was fun. I told you. Similarly, automation class will be fun. Don't bunk it. Online guys, we are done with today's topic, but don't quit the meeting. Please stay in the meeting. Okay. Online guys, any doubts in today's class? We finished WLC lab, QoS concept, and VPN. This is just a basic introduction to VPN. Okay, there is a lot more to learn about VPN that you will learn in CCIE security.